Welcome again. In this video I'm going to talk about how to summarize data and how to use dplyr in R to make that very efficient and painless. But firstly, why would we summarize data? So the point there is to really try to convey important information about the data in as few words and numbers as possible. There might be two aspects to convey. One is the central tendency, so what's a typical value in the data, and the other is the dispersion. How far, how close are the values to that central tendency? There are different measures for both dispersion and the central tendency. We'll talk about them in turn. So firstly, how do we talk about typical values? I like this example of running a shoe shop. So the first question might be, how do we split the shoes between two floors? For that, it would be helpful to look for the shoe size, where exactly half of the shoes are smaller, the other half are larger. And that's what we call the median. So in the median, we sort the values and we take the value exactly in the middle. We might also want to decide which shoe to present up front, and they would be interested in the most common size. It's called the mode, the most common value. Many European languages, die Mode, la mode, la moda, le mode, use it as a word for fashion. So the mode, the most fashionable, the most frequent value. And then if we actually want to compare whether more expensive shoes, whether the shoes bought in December were more expensive than the ones bought in November, it makes sense to use the mean, what we probably commonly understand is the average. And that's the total divided by the number. So our total shoe sales divided by the number of shoes that we actually sold. How do we choose between these three measures? Well, the mean is certainly the best known, the most popular. It's probably what many of us think about intuitively when thinking about an average. It's also accurate because it uses all available data. So it's sensitive to changes in any of the data points. However, that also means that it can be quite easily distorted. If there are a couple of extreme values, then they affect the mean in a way that it might actually no longer be typical. If we look at wealth, a couple of super rich people inflate the mean wealth so that that average isn't typical of anyone anymore. There it might be more suitable to pick a different number. Similarly for life expectancy, if some children die very young, they might reduce average life expectancy in a way that the new number isn't typical of anyone anymore. In such cases, it might be worthwhile to consider the median, which is exactly this halfway mark. And that's quite good because it is most representative when there are outliers, and it actually might describe a typical experience for someone just in the middle of our distribution. The mode is the only of these measures that makes sense for categorical variables. So if we ask people what's your favorite supermarket, there will be a modal response that we might want to report. But in many cases, we would then be more interested to give the distribution or to give the top three or something like that. So the mode as a real measure is actually quite rare. How do we calculate them in R? So I just created a little data set of incomes here. NA means that that data point is missing. And then to calculate the mean is very straightforward. We just say, we call the function mean, we give it the data, and we give it the argument NA remove equals true. We need to do that because otherwise R will complain that there's a missing value in there. This is equivalent to taking the sum divided by the number of entries, by the number of incomes. Of course, we would never take this long way around when there is the shortcut function. The median, likewise, we just call as a function. For the mode, however, there is no inbuilt function. The mode function does something different. If we want to calculate the mode in R, I found this version on Google. We probably won't need it. If you look at this mean here, it looks super accurate. It goes all the way down to 29 cents. that of course is completely meaningless. Our salaries were given to us in $1,000, so it makes no sense to talk about individual dollars. The very clear guideline that we should see as a rule is to round summary statistics to 1 decimal point more than what they were given. So the average of 10 and 15 is 12.5. That 0.5 makes sense. Any further decimal places should go. So in this case here, we would report the mean income is 40.7. Looking at dispersion, an interesting example might be considering exam scores. So the first question might be, how far apart were the lowest and the highest scores? That's what we call the range, and it's literally just the highest value minus the lowest value. That's of course very susceptible to outliers. So a similar question might be, how far apart were the strong and the weak students? And that we might define by percentiles. So we might say, well, the 25th percentile or the first quartile, those are the same thing, is the point where 25% of the students performed worse. The 75th percentile or third quartile is where 75% performed worse. So we can compare those 2 points. They then sandwich the middle 50%. And if we want to answer the question of how far from the mean a typical value is, we might use the standard deviation. It's quite a complicated calculation, but it's essential for inferential statistics. So it's essential for deciding whether differences we observe can be extrapolated to a larger population. We'll get to that much later in the course, but that's one of the reasons why this measure will show up a lot. How's the standard deviation actually calculated? It's a 4-step process. In the first step, we would subtract the mean from each value to get just the distance of each value from the mean. And the next step, we square these differences, partly to get rid of the minus signs. Then we take the mean of the squares, that's called the variance, and then we take the square root of the variance, which then gives us the standard deviation. You will never need to do this by hand, that's what computers are there for. However, there are 2 things to remember from this. The one is that the deviations are squared, which then implies that the standard deviation is not the average distance, but it is a measure that gives extra weight to observations that were far away from the mean. So an important thing to consider when there are outliers. Secondly, it's helpful to remember that the variance is the square of the standard deviation, because the variance will show up from time to time in more advanced statistics. You can calculate them all very straightforwardly in R. We have another set of exam scores here, again with a missing value. The range is calculated using the min and the max function. And again, we need to tell R to drop the missing values. In this case, I'm abbreviating the true with the letter T, that also works. The IQR has a special function for it, the interquartile range, so 75th percentile minus 25th percentile. And the standard deviation also has a specific function for it. There's also a variance function, and if you want to test it, the standard deviation squared is the variance. There's a new plot type that we can use that shows us many of these values in a single figure, and it's helpful if we want to compare the distribution of a variable across different groups, which is the same as saying across a categorical variable. So here I'm showing the distribution of national life expectancies in Africa and in Asia. For both of them, we can see the interquartile range, which is just the highest line, that is 75th percentile, to the lowest line, the 25th percentile. That tells us how spread out the majority of countries is. We can see the median, that's just the line in the middle. We can see the range, which goes from the end of the line at the top to the end of the line at the bottom, apart from the cases when there are outliers. What's shown as separate dots are outliers that are values we should look at again. And there are many debates how to define it, how far away a value should be. This is the standard setting in ggplot2, which is really good for data exploration. Now the question would be, which are those two countries, and do they tell us anything interesting about the question we are looking at? Okay, moving on to dplyr. What's dplyr? Dplyr is a package to write R code in a different way using pipes, which allows us to write it step by step and to use easily comprehensible verbs, so functions that are very easy to understand. That allows us to translate code that's quite complicated, where it's also very easy to make mistakes, like the first version here, into something that you can read and understand, like the second version. You don't need to understand the first one in detail. It's just worth pointing out that the square brackets indicate subsetting. So there we say we want to access specific rows and or columns of the data frame. We wouldn't use it for anything this complicated. There, dplyr is always preferable. Here dplyr, we say gapminder, filter for the year 2016, and then select life expectancy and GDP. The pipes, the percentage greater than percentage operator, just says take what's on the left hand side and put it into the function on the right hand side as the first operator. So in this case, gapminder pipe filter year equals 2016 is the same as filter gapminder year 2016. Writing it sequentially just makes it a lot easier to do many things in a row without the code becoming hard to read. There are quite a few different dplyr verbs, but just a few that are really essential and that you will be using quite a lot, particularly when it comes to summarizing your data in various ways. So these verbs are filter. Filter only retains the rows that meet certain conditions. Then we have select. Select only retains the variables that you're listing, or you can also use it to exclude variables with a minus sign. Next we have summarize. That then allows us to summarize all the rows that we have, filtered or not, on any of the variables that you specify, or you can use summarize all to summarize all the variables. That's particularly powerful in combination with group by, where you group the data set by some categorical variable. We'll have an example for that in a moment, but if you do that, then you get summaries for each of the groups. And lastly, there's mutate. Mutate allows us to create new variables out of the data already in the data frame. So one example of a chain that shows how dplyr can actually simplify our programming a lot would be if we have this task. So we want to make a table of means and standard deviations by continent for each decade for these two variables. Without dplyr, they would require a lot of intermediate steps. With dplyr, we just need to think about how to break this down in a number of specific actions. So the first action would be to mutate to create this new variable GDP per capita, which is just GDP divided by population. Now we have all the information we need in the data set. So next, we filter it to only have 1 year per decade. I'm doing this as this modulo operator here that just tests whether the year is divisible by 10. Alternatively, we could also just give it a list of the years we're interested in. But now we are filtering for this 1 year per decade. Next, we then group by continent and year, because that's the grouping we're interested in here. Then we select the variables we want to summarize, and we say summarize all. And then I can give the summarize all a list of functions, in this case mean and standard deviations. If I'm interested in other things like the interquartile range, I can just make this list longer. And then I get my summary statistic for these groups. We're going to practice this in class, so don't worry if you haven't followed this precisely. The key thing to remember about dplyr is the function of the pipes. So you take what's on the left-hand side and you give it to the right-hand side as the first argument, to the right-hand side function as the first argument. and to understand this idea of verbs. The dplyr tries to have functions that are just clearly actionable. And with practice you will remember them quite quickly. So I'll see you in class.